All right, those of you at home, here's your warm-up. Do the best you can on it. You're going to want to pause the video, see if you can simplify those, and if not, don't stress. We're going to do it right now. Pause the video, do what you can with those, and then rejoin us, and we're going to take a look at those, because these actually factor really heavily into what we're up to today. Let's see, it's the 114th day of school. You know, 114 is the smallest value yet to be represented as a to the third plus b to the third plus c to the third, with a, b, and c being integers. Let me explain. Give me a number between 1 and 10. Now, let's see here. Sophie, give me a number between 1 and 10. 9. So, 9 to the third plus, give me a number between 1 and 10. That's going to be, Oliver. 5. We're going to go negative 5 to the third plus, let's see here, and I want one more, and that one is going to come from Molly. One more number. 2. So we'll go plus negative 2 to the third. So if you actually add those together, 9 to the third plus, plus negative 5 to the third plus negative 2 to the third, get 596. So that's one. You can write 596 as 3 numbers being cubed added together. But 114 is a number that we think can be written that way, but no one's found it yet. But everything under there has. Like 113, we know it. 18, we know it. 42, we know it. It's National Sticky Buns Day. Sticky buns, like cinnamon rolls? Wait a minute.
I know cinnamon rolls.
Okay, yeah, sticky buns are cinnamon rolls. I was gonna say, if Jayla doesn't know what, if you didn't know what cinnamon rolls were, I would be like, here's what I want you to do. I want you over the weekend to go into a cafe blindfolded and say, I would like your best cinnamon roll, please, and sit down and wait for it to get to you, and then take off the blindfold and be blown away by its beauty, majesty, and deliciousness.
I just thought that was something else and not cinnamon roll.
I think it's like a specific kind of cinnamon roll. Like you have to actually like make it, like saturate it with sugar and make it even better. It's also Go Gluten Free Day, which I feel like that's messed up because like it's like this. Guys, today's Go Gluten Free in solidarity with those who can't eat gluten. And everyone's like, sounds good to me. And then someone else is like, who wants sticky buns? And everyone's like, yay, me. And then the person who can't eat gluten is like, you know, for the record, I also want sticky buns. I just can't have them, right? All right. Let's see here, guys. What's our first essential question? And I'd love to get that from Sir Bronson. Yeah, go ahead and write that down, guys. How can I truly simplify? So we've been simplifying them, but not all the way, if I'm being completely honest. Simplify, simplify the power expressions I'm working with on paper. The power expressions I'm working with on paper. That's how you get a 4. To get a 4 on your skill check on Tuesday, you need to not only have everything correct on Canvas, but on your paper, everything needs to be truly simplified. And I'm going to tell you what the difference is in just a moment. But in the meantime, guys, Hero Group acronyms FF. Funky Feet. I do not know about the Funky Feet. Does anyone know what FF might stand for Hero Groups? Yeah. Not Freaky Friday, although I hear that movie's fun. Yeah. It's the Fantastic Four. Luke got it. Fantastic Four. And guys, does anyone know that's blank key? It's tricky. Nope. Nope. Yeah, turnkey. Turnkey is the correct answer. What? I'm sorry. I didn't hear. I did. You did. I'm sorry. I might have been saying no to someone else, or I might have misheard you. I'm sorry. Anyway, let's get to these, guys. We're going to simplify these because the first step to simplification is really just to do this normally. So I see this orange problem of multiplication inside these parentheses. And I see this green problem outside of parentheses. So what would you like to tackle first? Reese, do you feel more comfortable dealing with the orange problem first, or do you want to do the green problem first? Green, that is absolutely allowed. It is not what I would do. But Reese, let's do it, okay? Because you can. Shh. Let's look. So guys, let's put down all the secret exponents, if you haven't already, into here. Now, Reese, I have all these exponents in blue, and I have my exponent in green out here. Do you remember what I'm supposed to do with all those blue exponents and that green exponent, Reese? That's exactly what you do. So we're just going to do that. So 3 to the negative 3 to the negative 1, I'm just going to put that in my calculator. Negative 3, and remember, if it's a negative, we want to put it in, sorry, to the negative 3, because it was 1 times negative 3, is negative 1 over 27. I'm just going to write it down. Negative 4 times negative 3 is positive 12. Positive 2 times negative 3 is negative 6. Positive 9 times negative 3 is negative 27. 2 to the negative 3, I do not know what that is. 2 to the negative 3. 1/8. 1/8. And that's okay. Times 1/8. And then that's going to be q to the negative 3, r to the 21, because that's negative 7 times negative 3, s to the negative 6. Who doggy? So that was a lot of work. But Reese, do you see how we got all those numbers? We just punched it into our calculators. That's all we had to do, was punch the coefficients in our calculators and then multiply all our exponents. So this is a thing. We've got it. Let's see here. I've got coefficients in blue. I've got my variables with their exponents here in yellow. And on Canvas, very important, on Canvas, it would look like blank, q to the blank, r to the blank, s to the blank. Okay, great. Josh, do you want to help me fill in the yellow boxes, or do you want to help me fill in the blue box? Sure. How am I going to fill in the blue box? Oh, we actually already did that part. That's the thing. You did this in the other order. So you did the inside first and then did the outside, which is how I would do it. But I wanted to prove the point that if Reese wants to do the outside part first, you can totally do that on these. So think of this as a totally different problem. We've already dealt with this part. So let's just pretend this doesn't exist anymore because we already handled it. Look, now there's very little evidence it existed, but how many of you are annoyed by the small bits of evidence that are left behind? Haha, I will leave them there for you. All right, so do you want to help me fill in this? So you want to help me fill the blue one. So what am I going to do with these two blue numbers in order to fill that guy in? Yeah, we're just going to multiply them. Negative 1 over 27 times 1/8. And it's going to give me this weird fraction, and I'm going to be like, all right, negative 1 over 216. Exactly. And I'm going to tell you right now, that's all I want for Canvas. If you can get that number, you're going to get a 3.5. You're going to get a 3.5 if you're getting that number. Now I need some help with those yellow boxes. Let's see here. Can I get a bit of help? And that's going to come from drawing empty seats. There we go. Malia, what am I going to do with all those? I forgot how colors work. I apologize. What am I going to do with these yellow exponents? Do I add them, subtract them, multiply them? What do I do? Yeah, since we're multiplying powers with the same base, we add their exponents. So we're going to do 12 plus negative 3. 12 plus negative 3. And that's 9. Negative 6 plus 21. That's 15. And then negative 27 plus negative 6. Oops, that is not a 6. Negative 33. That's it. How many of us, by raise of hand, either got that or see how we got that and aren't too concerned about it? You guys doing okay? Because you don't have to go in the same order that Reese had us go. You could go in the other order where you multiply the insides first and then do the exponents. How many of us liked it? We're going to do it the way that Reese did it, outside in. How many of us want to go inside out? Guess who's right? Everybody. I saw a question up there. Yeah, go ahead. Sorry, guys, can't hear Gavin. Oh, I got you. It's because, let me just put this back. That's actually really hard to do. There we go. It's because, Gavin, coefficients have a secret exponent, and that secret exponent is 1. And when I raise powers to powers, I don't multiply q by negative 3. I don't multiply r by negative 3. I multiply their exponents by negative 3. So the negative 3 was to the first, so I did 1 times negative 3, and that became negative 3 to the power of negative 3. That's how that happened. Great. Listen up.
Good morning, everyone. We would like to thank everyone who participated in the Resilience Challenge a couple weeks ago.
Oh, yeah.
And the teachers for selecting their 5 top students in each class. We have done the drawing, and we've got 5 winners from each class or each grade.
I better mute this. They're going to have last names here in just a second. We're still here. We're just waiting for them to finish the names. Or maybe they're done. Okay. The end. All right. So on this next one, got.
Okay. In 7.
Yeah, go get your prize. Congratulations, you two. And don't forget who nominated you. All right, it was me. All right, let's see here, guys. We are running pretty low on time, so I think I better take care of this right now. This is how you get a 4. Guys, this expression, if you write it on paper, and in fact got a pencil, is 1 over 216 q to the 9th, r to the 15th, s to the negative 33rd. So to get a 4 on this, guys, we need to write this so that it has no negative exponents. And we do it like this. Do you remember way back when I told you that a to the negative 3rd is just 1 over a to the 3rd? It was that's okay, don't be sorry, it was a long time ago. But that's true. When you see a negative exponent in this string, it belongs downstairs with a positive exponent. If it's got a positive exponent, it belongs upstairs with a positive exponent. So, if I have a fraction, guys, does q go upstairs with a positive exponent or downstairs with a negative exponent? It goes upstairs because it has a positive exponent, q to the 9th. Does r to the 15th go upstairs or downstairs? Upstairs because it has a positive exponent. Does s to the negative 33rd go upstairs or downstairs? It goes Because it has a negative exponent, it goes downstairs and the exponent becomes positive. Now we have to deal with this, guys. Does 216 go upstairs or downstairs? Downstairs. It's already there, right? It's already in the denominator. And 1 times anything it says itself, so negative 1 times all this would just give us a negative like that. That's okay. That was the only time we got to look at it because we got those interruptions, and I apologize. Folks, I want that just to cook, and we'll talk about it a little bit more on Monday before we do your self-assessment and get ready for our skill check on Tuesday. That's all we have time for. Put your calculators away, and lo, I will dismiss you with the bell.